Okay, welcome back. We have the answers here for exercises 3 and 4 on worksheet number 3. If you did not arrive at these answers or you have need additional help to understand how we did arrive at these answers, circle them and contact me and we'll work through them. Alright, that is the end of section 2. You have moved on to now, by choosing this video already, Construction Math Section 3. So let's get started. We are going to be covering some what we call advanced calculations. Refer to them as advanced calculations, not really because they're more difficult, but just because they're operations and exercises and problems that you probably don't do every day on a daily basis. They're not just, the basic everyday. So some of the things we're going to cover are averages, perimeters, circumference, area, and volume. We're going to learn how to compute all of those. So let's start with average, something probably most of us do work with, if not every day, then quite often. Average is the sum of all the numbers that you're averaging. And when we say sum, that means adding them up. That's on the numerator. The denominator is the number of numbers that you're averaging. Okay? So for example, below that we have what is the average foot size for a group of men who wear the following shoe sizes. So we have, looks like 5 men there, all wearing, basically different size shoes. We got 2 size 10s there. So for the numerator, what we do is add up all those numbers. The denominator, we count the number of numbers. So we've got 5 numbers that we're adding. That's what goes on the bottom. When we do that, we have 57 over 5. The average shoe size for those 5 men is 11.4. So just to wake your brain up and have you do a couple of averages, I'd like you to go to worksheet 4 and complete exercises 1 through 3. When you have finished those, then resume the video and we'll continue on. Okay, hopefully you arrived at these answers for exercises 1, 2, and 3. If you did not, try to work them again and see if you can get these answers, and if you have problems, contact me. So averages was pretty simple. Perimeter also. Perimeter, we're talking about the linear distance around a flat object. Okay, so if you could take a rope and take it around something, or around a square, around a circle, any shape, and wrap it around there, and then straighten that rope out and measure it, that's the perimeter. Okay, it's a one-dimensional quantity. And if we have sides of a square or a hexagon, an octagon, whatever, we're adding all those sides together to get that perimeter. So here's an example, pretty basic, of a rectangle. 2 of the sides are 10 feet. This could be just a room, a typical room. 2 of the sides are 10 feet, 2 of the sides are 4 feet. If somebody asks you what is the perimeter, they're asking you, what is the length around that room if we add all of those together. So we're basically just adding those together. And the perimeter is 28 feet. Okay? So that was a pretty easy concept, and probably for all of you a review. So pause the video and complete exercises 1 and 2 on worksheet 5. And when you are finished, resume the video and we'll continue on. Okay, here are the answers for worksheet number 5, exercises 1 and 2. Pretty simple, right? Just adding those 4 sides together for number 1, and adding, we have a triangle, the 3 sides together for number 2. Remember to always include your units, especially when you're taking an exam. If you just added these numbers and said 12 and 18, on an exam you would probably get that wrong, or at least partially wrong. You want to make sure, because obviously it's very important on the job, whether you're working in feet or inches. So always include the units in your answer. Circumference of a circle, we're still talking about the same thing. What's the linear distance around that circle? However, we don't have straight sides that we can measure. So whenever we're dealing with circles, when we have to find the radius, or the area or the volume, we have to use this number pi. I know you've heard of it before, you're all familiar with it. But that's when we're working with circles. Pi is going to be involved if we're going to calculate something. So to find the perimeter of a circle, it's pi, this number pi, times the diameter. Okay, so the diameter, if you go through the middle, it's straight across from one edge to the other through the middle. That is the diameter. Keep in mind the radius is always half the diameter. So if you're given the radius and somebody asks you for the circumference, if you double it, that's going to give you the diameter, and that will work as well. So I show that here. 2 times the radius times pi will also give you the circumference, or pi times the diameter. Now pi, when you punch it into your calculator, if you've got that in front of you right now, you're going to get a string of numbers, a very long string of numbers. If you use the calculator pi, because of all the numbers that go past the decimal point, that will give you a different answer than if you use the abbreviated value of pi, which is 3.14. So you'll see as we work through here, and if you do that for all of your calculations, you'll see how that can give you a different answer. So when you're taking an exam or when you're out in the field, make sure you know what value of pi whoever you're working with would like you to use, whether 3.14 or the full value of pi that you have in your calculator. So here's an example of calculating the perimeter of a circle. We have a manhole that has a diameter of 48 inches. Somebody says, what's the circumference? So we take the value of pi, which is 3.14, times the 48 inches. That gives us a circumference of 150.72 inches. Alright, so now that we've covered the perimeter of a circle, turn to worksheet 6, pause the video and calculate the perimeters of those two circles. When you're finished, resume the video and we'll continue on with the answers. Okay, so hopefully these are the answers you did arrive at with the for number 1 and 2 for the circles that we were given on the worksheet. If not, run through them again, make sure you punch the right numbers in the calculator, and you do arrive at these answers. So that was, we talked about perimeter. Like I said, it's a linear distance. We're just talking about measuring, one flat, basically a line around something. Now we're going to talk about area. Area is basically the amount of space inside the boundary of a flat object, two-dimensional object. So when I talk about the area, the area of a sheet of paper, the area that it takes up when I put it on the desk, that, the flat space, the amount of space that it takes up. The area of a sheet of drywall, a disc. So we're talking about just two-dimensional objects that don't really have any height to them. We're just talking about this flat space they take up. For example, here's a rectangle. If we wanted to know the area, like I said, and when we talk about, especially within a home, we talk about an area rug. That's what we're talking about. How much area does this take up? So area of a rectangle is length times width. Okay? And that's going to tell us how much space this takes up. So an example, we have a driveway that's 18 feet wide and 32 feet long. Somebody says, what's the area of that driveway? So you know how much material you need for that driveway. So we're going to take the length times the width, and that's going to give us 576. Remember, square feet, because we have 32 feet by 18 feet. And as we recalled earlier, when we're talking about area, we've got square feet here. This is linear feet. This may be 8 feet here or 32 feet, whatever we have. But if we're talking about all this space in here, we're talking about square feet now. So in area, we're talking about square feet. Alright, that was pretty easy. So go to worksheet number 7, pause the video, and complete exercises 1 and 2. Alright, so on worksheet number 7, exercise number 1, pretty straightforward, right? It's a rectangle that is 7 yards by 4 yards. So that's a pretty simple calculation. You end up with 28 square yards. Number 2 kind of threw a little curve in there for you. You're given an odd shape that looks like, something's been cut out of it. If that was a sheet of drywall, there's been a square or something cut out of it. And we need to know what is the area of what's left there. The easiest way to do that is to cut that, look at that as two different rectangles and calculate the area of each one separately and then add those together. So I've done that here in 3 steps. Step 1, I computed the area of the first rectangle, which is the bottom one. 7 feet on the one side, 11 feet across the bottom. Okay, when I do that, that big chunk there is 77 square feet. That little piece on top there, then I have to figure out what's the dimensions. And I do have to calculate the dimension on the side there. I know 3 feet across the top, but what is that little chunk right there? We know that the whole line, that whole side there is 12 feet, and we have 7 feet on the other, so 12 minus 7, what's left is 5. So we know that other dimension on that box is 5. So 3 feet by 5 feet is 15 square feet. Add those together, we get 92 square feet. Hopefully those are the answers you arrived at also. So area of a triangle, we're moving up in complexity a little bit here. You may have a triangle that you need to compute the area of as well. The formula for that is 1/2 times the base times the height. So we're still looking at, two linear measurements that we're multiplying together. However, we don't have a full rectangle here, okay? So it's 1/2 the base times the height. To know what the base and height are, if you were given an example on an exam, hopefully it would tell you which is the base or height, but if it doesn't, the base and height are defined in relation to each other. The height is always perpendicular to the base. That little square there means it's perpendicular or at 90 degrees. Okay, so it's 90 degrees and it goes up to the top of the triangle here. Okay, so this is the height and this is the base. So for an example, we have find the area of a triangle to the nearest tenth of a square foot. The base, we're told, is 4 feet and the height is 10 feet. So it's 1/2 the base times the height, and we calculate that out. It's going to be 20 square feet. Alright, so now we're going to have you compute the area of a couple of triangles. So pause the video, go to worksheet number 7, exercises 3 and 4. When you've completed those, resume the video for your answers. Okay, there's your answers for numbers 3 and 4 for those two triangles. And hopefully those are the answers you also have, and you have the correct units as well. Area of a circle. We have a circle, we've got pi involved. So the area of a circle is that number pi that we talked about times the radius squared. Okay. Remember again that radius is half the diameter. And if you have trouble remembering the distinction or remembering the difference between radius and diameter, radius radiates out from the center to the edge. Okay, so that is the radius. And you remember squaring it is just multiplying it by itself. And if we use pi as 3.14, that will give us our answer, the radius and pi. That's all we need. Pretty simple, right? So what is the area of a retention pond that has a radius of 15 feet? We multiply pi times the radius squared, and that answer should be 706.5 square feet. Fairly simple, right? So of course the next step is for you to do a couple of these yourself. On the back, flip the page for worksheet number 7 and you'll see problems 5 and 6 deal with circles. Compute those areas. When you've completed those, resume the video for your answers. Okay, those should be the answers for number 5 and 6 on worksheet 7. Area of a trapezoid. So probably more often than not we have odd shapes out there in the universe that we need to measure and calculate either areas or volumes. If you have a trapezoid, basically what we're saying is you have two sides that are parallel, okay? We call those base 1 and base 2. And then you may have two sides that are not. If they were parallel, this would be a square or a rectangle. However, they're not, so we kind of have a triangle and a couple of triangles and a square is what we end up with here. So the formula for calculating the area of this type of shape is 1/2. Going back to kind of when you've got that triangle in there, it's 1/2 base 1 plus base 2, these two parallel lines, times the height. And again, the height, remember from when we're talking about triangles, it's perpendicular to the base, or at 90 degrees. Okay, so 1/2, adding these two bases together, and then multiplying times the height. So here's an example. The area of the trapezoid below, we have a base 1 of 13, base 2 of 29, so we're adding those together, okay? And that gives us 42. 1/2 of that is 21. So that's bringing all of this down right here. And our height is 15. When we multiply that by 15, we get 315 square feet. You'll notice out here on the edges, these number 17s. You don't really need those to calculate this problem, do you? You need the bases and the height. These we don't need for this because we have the other information. You may find in a test that you're given more information than you need. There may be information that is not relevant to the particular problem you're working on. So sometimes the challenge is not only finding the information you need to complete the calculation, but also ignoring or discarding the extraneous information that is not necessary. Okay, so pause the video again and complete exercises 7 and 8 on worksheet number 7 and resume the video once you are finished. Okay, you guys probably are very used to the drill here now and are really solid on these answers and getting this right. So basically we have, for the first one, we've got the base and the height, 3 foot plus 6 foot, right? And we have the height, which is 4 feet. So we've got all the numbers that we need. You notice we also have that 5 foot in there. Again, that's that extraneous, that doesn't help us with this formula. We've got base 1, base 2, and we've got the height of this trapezoid. That's all we need to calculate and get the answer, 18 square feet. Okay, so let's move along. That is the end of section 3. We covered area of various different shapes. We're going to move along to section 4. We're going to start talking about volume. So you will begin the next section by starting video construction math, section number 4.